In this video, I'm going to show you how to solve linear systems by a graphing method. It is not the most accurate method, but what you'll be marked on is the process more than the actual result that you get. So we're going to start with this question here. Student council is deciding which banquet hall to book for this year's graduation dinner and dance. Thompson Hall charges a fixed cost of $1,200 plus $35 per student, or per guest, I guess it should read. Adeline's Country Club charges $1,000 plus $40 per student. We want to write a system of linear equations to represent the situation. So first of all, you should notice that this word per indicates that this $40 is a rate of change, and rate of change is our slope. So if you record $40 per, so this division line is per student, and remember that slope is rise over run, or change in y over change in x, this allows you to find out what is the variables going to be. So the y is on top, which is dollars, so let y be total cost, and x is on the bottom, which is student, so we can say let x be number of students. Now we're going to create an equation for this. So Thompson Hall y equals, so this y here would be the total cost, equals, and then beside the x we're going to have the rate of change. So this is going to be in the form y equals mx plus b. M is going to be the slope, which we already have here, 40, and then the b will be the initial value, which is $1,200. Then you repeat the same for Adeline, and you have 40x plus 1,000. So in order to solve this by a graphing method, we want to create some points for each of the lines to plot them. So 2 points is enough to draw a line. The easiest point to plug in is going to be 0. So if you put 0 and multiply 0 by 35, you get just 0, so $1,200, and that's how I got this number, and then $1,000 for Adeline. Next, we're going to take 20 for students for both of the equations, plug them both in for the x's, and evaluate. We get these numbers, 1,900 for Thompson and 1,800 for Adeline. Now that we have 2 points per line, we can start to sketch. That's all we need, 2 points to draw a line. There's going to be a problem with this. Let's see what it is. Since our x was number of students, we're going to place students on the x-axis, and we have 0 and 20. I used 1 student is equal to 1 square for this particular example. And make sure you label your x-axis, your y-axis, and give it a title. Please remember that cost depends on students. So on the y, you have to place the dependent variable. On the x, you place the independent variable. Do we need a break for the total cost? I say yes, because the numbers that we have here are nowhere near close to 0. So I'm going to use a break and start from the lowest number, which is 1,000, and our highest number is 1,900. So I'm going to say I will count up 20 squares and make that equal to 1,000. So 1,000 plus 1,000 is the 2,000 that I have up here. So basically each square is going to be worth $50 per square if you divide 1,000 by 20 squares. So now I'm going to plot the green, which is going to be for my Thompson legend. So those 2 points are just above 1,000 and just below 2,000 here. Draw the line. And then I'm going to use a black color for Adeline. And we have just below the black point is just below the green one, and on this side is also that. So this is the problem. Just having 2 points is enough to draw a line, but that does not guarantee that the point of intersection between the 2 lines is captured within your domain. So why did that happen? Well, if you compare at 0 students, total cost for Thompson is 1,200, and it's a bigger number than 1,000 for Adeline. And when you grab 20 students and you got 1,900, it's still bigger than 1,800 for the 20 students for Adeline. So there was no swap between which one became bigger. And so POI is not captured. It's somewhere off the grid It's further on for more students than just 20. So let's go back and add another value for number of students. Let's choose something bigger, so let's say 100 students, and plug that in for the x's. Find the y values that correspond, and we get 47, 100, and 5,000. This time, 5,000, as you compare it to 4,700, it is a bigger number. So definitely within this domain from 0 to 100, we have a point of intersection somewhere in between. So this is now ready for sketching. So I'm going to plot the first and the last point. We really can ignore that middle point. Before I do that, let's discuss how to choose a scale. So let's now look at the range of numbers for x. The smallest number is at 0 and the biggest is 100. So the range is 100 students. The number of squares on the x-axis, as we know, is 27 if you were to count. And so for the scale of x, you can just divide the bigger number by the smaller and get roughly 3.7. This would be very awkward to use, so you want to round this either up or down. In this situation, we're going to round up and say each square is going to be worth 4 students. So if you look at that, counting by fours, we have 4, 8, 12, 16, 20, and then so on. And technically, you will learn in grade 11 that for the independent variable, we actually don't use the word range, we say domain of numbers, but just think of the word range as the difference between the biggest and the smallest. So let's do the range for y. So in grade 11, the y value will always have the word range associated with it. So the biggest number here is 5,000 and the smallest is 1,000. So the range for y is 4,000. Do we need a break here? Yes, we do, because the smallest number is nowhere near 0. The number of squares on the y-axis, there is 26 squares if you were to count them, but we will need one of the squares to fit the break in. So choosing the scale for y, we're going to take this range, 4,000, and divide it by 25 squares. That goes in evenly, 160. So 160 is awkward to count by, even though it's an even number. So we're going to round up and say every square is going to be worth $200. And so after the break, this first tick mark after that would be 1,000. And then you're counting by 200. So 200, 400, 600, 800. And then this is 1,000 on top of original 1,000. So that's 2,000. That's 3,000, 4,000, 5,000. So we're going to use green again for Thompson and plot the first point and the last point. So the first point is $1,200. So after 1,000, each square is worth 2,000. So we can go just one square up. So that's there. For the biggest number is 4,700. So if we go to 5,000, 200 squares down would be 4,800, but we need 47. So it's going to be in the middle of the next square. Draw the line. Then what you want to do is sketch the first and the last point of the second one, which is Adeline. So the first point is 1,000. That's right there. And the last point is 5,000. Plot it there and draw the line after. Make sure you draw the line after you do the points, because if you just plot all 4 points, you might not know which point connects to which. Okay. Don't forget to label your lines with what they represent. Now we're going to go on to state the point of intersection. So we have here a circled value that looks like the POI, and we have to estimate this. Later on, you'll be learning methods, elimination and substitution method, which is going to be purely algebraic, no graphs. And they're going to give us exact values. But graphing method, you have to estimate, unfortunately. So let's discuss this. We have on the x-axis, it looks like it's 1 square below 40. Each square was worth 4 students. So I'm estimating this to be 36 for the x and 2,400 for the y, because that looks like it's right here. So 2 squares above 2,000. So that's 200 plus 200. So 2,400 there. What does this point represent? At about 36 students, both halls charge, my R looks like an N, sorry, about $2,400. So they both charge the same. So for huge parties with lots and lots of people or students, Thompson Hall is cheaper. So if you look at the bigger number, Thompson Hall has a lower total cost than Adeline, just looking at the graph. So it's very useful to make those types of decisions if you have some graphs to compare your results with. Now, we don't know whether this 36 students is actually the accurate prediction, so let's do a check. So when you're doing a check, it is important that the point of intersection doesn't just satisfy one of the equations, it has to satisfy both. So we're going to plug in 36 for x and 24 for y for both of the equations. Doing so in this first one yields slightly off result. So our point is definitely off, but we don't know how much, and at this moment don't worry about it. Just state what you're guessing, and then later on we'll learn a better method to find exact values. And looking at it in the second equation, it is also off here. So we can just say POI is a bit off, but it gives us a rough idea where the point of intersection could be. Let's try another type of question where when you're choosing a scale, you might not have to be rounding up, you might have to be rounding down. So I want to explain that. So for this example, I'm choosing an example that has smaller numbers. So here we have at a bowling alley A, Angela rented shoes for $3 and it cost her $2.50, so $2.50 to bowl each game. While at a bowling alley B, she paid $3.10 per game, and the shoe rental was included. Which alley should she choose to use? So we're going to start by writing linear set of linear equations. So a system just means there's going to be two equations. And in this question, the word each is the same thing as the word per. So the 250 represents the slope. So dollars per game allows you to figure out what is your y value and what x value could represent. So y will be total cost, x will be number of games. So alley A is going to be rate of change multiplied with x plus the initial fee of $3 for the shoes. But, alley B will have just $3.10 per game, but no initial fee, so plus 0. So in this table, we'll have A's here and B's values here. Again, use 0 to start with. So if we have 0 games, alley A, you'll have to pay for the shoes, which is kind of silly to go in, just pay for the shoes and not play a game. But remember, we're just creating a point to graph. For alley B, we'll have 0, 0 because there's no initial fee. We compare 3 with 0. Definitely there's a bigger value for alley A. So let's grab 2. When you plug in 2 into both equations, you would get 8 for alley A and $6.20 for alley B. And if you compare 8 with $6.20, the 8 is a bigger one. So we know that we have not captured POI, point of intersection between 0 and 2 yet. So let's take another number, let's say 10. For 10 games played, if you put those into x's here, we get 28 for alley A and 31 for alley B. And 31 is a bigger number than 28, so we know that these set of points will be enough for us to sketch. So we're going to take that and decide on our scale this time. So range for x, so biggest to smallest, there's 10 games. There's still 27 squares. So when you're doing this division, this time we have a 27 is the bigger number. So 27 divided by 10 gives you 2.7. So that's awkward. And you might say, oh, it's close to 3, so let's just round up. Let's see what happens when we do that. So 3 squares represents 1 game. So 3 squares, here's 1 game. 3 more squares, this is the second game. Notice what happens when you're trying to go to 10 games, you're going to be off the grid. So instead of rounding up, let's round down. So we're going to say 2 squares is going to represent 1 game. And when you do that, that gives you tend to be not at the very edge, but that's okay. As long as it fits onto your grid, that's what you want. Then you do the same thing for the y's. So the biggest value here is 31, the smallest is 0, so range for y is 31. There's 26 squares, and we do not need a break this time because we are using 0 as a point, and all the values are close to 0, so we have to not use a break. So the scale here, bigger number by smaller, 31 by 26 is 1.2 roughly, and here we can round up, and we could say it's $2 per square. So if in doubt whether you round up or down, just try it out and test out your scale. If you fit, do it with a pencil, great. If you don't fit, erase and try again. So counting by twos, 2 per square, so that's 2, 4, 8, 6, 8, 10. So that's going to be our total cost. Don't forget your title. Plotting A's, alley A with green, and plotting B with black. Then we're going to look at this point of intersection. We can estimate it to be at 5 games. It is about maybe $15. So at about 5 games, both alleys charge about $15. So for less than 5 games, so if you know you're going to just play 1 or 2 games, you're going to be looking 1 or 2 games. You're going to look at the y values, and it looks like the lower one is the black one, so you'd go with alley B. Let's check our point of intersection. So plugging in 5 into first equation gives us $15.50. So it's not exactly 15 that we guessed here. Let's check in equation number 2. Oh, we get 15.5 as well. So it looks like I was just reading off my graph here. I said it's going to be 15, but it's actually 15.5. So because they are the same, I can actually modify my POI to be 5 games and $15.50. If you cannot do that because it's too hard to estimate and you don't want to redo the question, don't worry about it. Leave it as an estimate and just say, I have an error in my solution. Last type of question. Not every question is going to be where you have y equals mx plus b format for the equation setup. So let me show you another one. This is going to be our last one. Joe invests a total of $4,000 in 2 different plans in the bank. Part of the money is invested at 8% per year, and the rest at 11% per year. The interest paid after 1 year on the 11% investment is $212 more than the interest paid on the lower percent investment. How much did Joe invest in each? So because we're given the total, usually total will be like y equals, so you can't have y as a variable by itself because we already know what that is. It's 4,000, so it cannot be the variable. So we're going to create one equation to represent everything about the money invested. So that's not the interest earned or anything like that. This is just money that was originally invested. So we know there's $4,000 to start with, but we don't know how much went for each part. So A and B is going to represent those 2 parts. A is going to be the low percent, the 8%, and B is going to be amount put in at 11%, the high percent. The second equation will come from the earnings, the interest earned. So first of all, 0.08 multiplied with A will be the interest earned on A only. So this is not an equation, I'm just doing the 2 parts. And then likewise for 11% on B is going to be this. Then you notice these words, 212 more than. So we know we have to add 212 within the equation. The reason why we add to this side with the A, because this is going to be a smaller amount, plus the 212 will give us the bigger amount with the B. Now that we have 2 equations, we're going to now, instead of using a table, let's just use intercepts. So in equation number 1, I'm going to find the A intercept by subbing in B equals 0. And I get 4,000 for A and 0 was plugged in for 0, so that's one of the points. Do likewise for b-intercept. In the second equation, we're going to find a-intercept by plugging in 0 for a, so 8% of 0 is going to be 0, so that's gone, and when you solve for b, you get roughly this number. For b-intercept, 0 is plugged in for b, so that side becomes 0 right here, and then you solve for a, and you get this negative number. So I'm going to record both of these points in a different color, so I can use that on the next page on our graph. So I have placed here my let statements because I need them. I have written down my horizontal axis will be the A, and the vertical axis will be the B. And this is arbitrary. There is no dependence here of independent variable and dependent variable. I could have had B on the x-axis here. This is just the way I chose alphabetically. That's fine. So we're going to choose a scale this time again. So the range of A's. So if you look at all the values in front of the comma, the smallest number is this negative number, and the biggest is 4,000. So if you subtract the two, you have a range of 6,650. The square on the a-axis will be 27 squares horizontally like before. And so when you divide them, you get this decimal, which we can round up to 250 per square. Let's do it for B. So look at all the numbers after the comma. The biggest is 4,000 and the smallest is 0. So when you subtract them, your range is 4,000. Squares along the b-axis is 26 squares. Divide the two and round up. So because we have some negatives, I'm going to start at the very edge of the grid and take my biggest number value for A, which is the 4,000. And for A, I'm counting down by 250. So 250 here, that's 500, that's 750, and that's 1,000 less. So I have 4 squares representing 1,000, and then just follow the pattern until you get into the negatives. Now the b-axis has to go along this 0 line right here, vertically up, but for now I'll just place it on the side and then I'll move it. So we are going to be counting by 200 per square. So 200, 400, 600, 800, 1,000, and just follow that pattern. And now move the b-axis so that it is at the 0 line here, and the a-axis is over here. And then we can just plot the 2 green points, 4,000 and 0, and 0 and 4,000. So that's pretty easy to do. And then the purple points, plot it, estimate it a little bit, that's okay. And so we could see the POI should be, let's see, if we were to estimate it, it would be 1 square away from 1,000. And we were counting by 250, so that's 1,250. And then along the b-axis, it is just 1 square below 3,000, and that was counting by 200. So that's going to be 28. What it represents. So A, remember, our let statements above. A is how much we invested at the lower percent, and B was how much we invested at the higher percent. Now all that's left is to do the check. So we're going to see how great this method is, or not. So plugging in A and B, if you add them together, we are off. It's not exactly the same. And here it is very close, but again, not quite the same. So don't redo the question and try to get it right on, just as long as you show your checks, show your grid, sketching, everything shown, just state at the end solution is not accurate, and you'll get your full marks. So hopefully after all of this, you'll look forward to a more accurate method of solving linear systems.